Hello, everyone. Welcome to Carbon Panel. I'm Hannah. I will try to moderate these three. Richard, John, and Chandler. I think you all know them, and especially Chandler. And my first question when Chandler asked me to moderate this panel, I told him it will be everyone follows Carbon at least a bit. And some people are excited about it, so when?
No pressure. So when is, it's a great question, it's an understandable question. First off, I just want to thank Hannah for actually choosing to moderate this. Folks may not know Hannah. She's chair of the Reflection subgroup of W21 and been a long-time committee member and is really, really amazing. And I appreciate her coming out here and moderating for us. As for when, when it's ready, right, is I think that's the classic open source answer. But we've tried to put out a roadmap. Planning projects like Carbon is incredibly hard. It is a very long-term project. It's not going to be soon. If people are like, can I use it tomorrow? That's not happening. The roadmap says that our goal for this year is really to get the tool chain that you can actually use to compile things caught up with the language design. We really want to start getting into building practical C++ interop this year. How far we make it in that, I think, is just a big question. There's so many unknowns there. I don't want to give too many predictions. But I think next year is when I think you're going to see a tool chain that kind of works, that kind of you can do interesting stuff with. You can kind of evaluate what we've been trying to do in a little bit more concrete context. And beyond that, we put some ideas in the roadmap, but I think beyond that's really just very speculative.
Okay. I think it was really hard to convince management in Google to start such project. So you definitely needed some good reason, technical reason, why are you going to do it? Do you have something you can share with us?
Sure.
Maybe Richard? Richard, Chandler. We have Richard also.
No, Richard, please.
Well, I actually think Chandler's probably a better person to talk to this because
our moderator has spoken.
He's more on the management side, but yeah, okay. So, I think we're always interested in exploring new possibilities for how to deal with our existing C++ code base, which is obviously a hugely valuable asset for us. And that includes both looking at how we can keep the C++ language itself happy and our tools for it being really good and maintainable, but also places we might take our code base in the future. And so this is something we've been talking about for a long time, whether we can build something that works better for our use case than the existing tools. And I think we found a really good time to explore that and went with it, really.
Yeah. The only thing I would add, since you keep looking at me subtly, is we were basically trying to make these improvements in C++ and all the things that you're talking about, but we weren't making as much progress as we wanted, and so we're just trying to look how can we kind of open up some avenue where we can make much more dramatic progress, much more rapid progress, explore much more radical ideas, maybe address more challenging problems than we've been able to in C++. We looked at a bunch of options. Carbon's not the only thing that I think is a really exciting option here. We had a talk yesterday from the Swift folks. I think Swift is an amazing option here. Rust is an exciting option here. I think there's a lot of different places to explore, but we felt like there were some unique opportunities that we could go after with Carbon.
Okay. Also, I followed Carbon a bit, and it's a huge project, and it's not just Google project. Everything is in open, and that's I think really useful for people to watch it. It's really hard to for people outside to just jump in because it's a lot happening. How do you manage it?
I think we try to support people when they ask questions as much as we can. We've gotten a lot of interest, certainly, but it does take time to stay in. Things like maintaining the project documentation, trying to write like even for a basic project like ours, trying to write a starter guide on how to build. We are making some different infrastructure choices. Like I know a lot of people are happy with CMake, but we're doing Bazel. But in general, we're trying to use GitHub, trying to use fairly standard action flows. We rely on Brew and other standard approaches as much as we can. I think there's probably still room for improvement. Listening to the newcomer roundtable a couple days ago gave me a couple ideas for how we could improve with a little of that. But I think at least right now, there's a lot of challenge learning how the different model works in Carbon.
We have some awesome open source contributors. It's, I think, hard to find people who are super excited to work on compilers. I mean, maybe not in this room, but in the world as a whole, I think it's rare for people to really want to do that. And
Yeah,
we've been lucky to find
We are
a few great people.
biased about it.
A little biased.
I remember like when we talked about Carbon a long time ago, you like highlighted the government structure. You set up rules and processes around like development of Carbon, and that's something unique because usually projects don't start with that. So Chandler, tell us something about that.
Yeah, I mean, governance is the thing I'm really excited about. I think most people are not as excited about like project governance, but I find it really fascinating. And it was something I wanted us to start off with when we were looking at problems that had emerged in the C++ standards process, and also in open source projects, even in LLVM. In my experience with LLVM, right there have been real challenges with governance. And one of the challenges was when a project gets big and has a lot of momentum, right? Even if the governance model that was set up originally stops working well for whatever reason, changing it is incredibly hard. And so I wanted to try and see if we could kind of set up front some real investment in getting a governance model that could scale and could change itself more easily as new requirements came in. I think we've been fairly successful with that, mostly because the first version was terrible. We actually had an initial governance model that was very elaborate. We had a large core team of people. We even pulled more people than are even active in the project right now into it, and we would have kind of weekly or bi-weekly meetings and try and talk through things. We had a very complex consensus process. And in some senses it worked in that like we were being intentional. It was clear, that there was a governance project, but it was so inefficient that like people couldn't use it. Like our own team just like couldn't use it. People were avoiding kind of going through the governance process because of the overhead. And so we kind of revamped the whole thing and simplified it. We kind of distilled it down to something a little bit closer to kind of the benevolent dictator for life model. But we tried to then just apply much more minimal patches to that model. So we have 3 leads instead of 1, so that we have some redundancy, right? Someone can go on vacation, it's not a big deal. But we just have one kind of top level governance body. It's 3 people. We're going to eventually kind of have a rotation there, so that we also have emeritus members who can step in if there's a gap, if someone needs to go work on something else. It's easy to rotate someone else in. But I think this works out really, really well. And a key thing about this is it's not like the 3 of us always sit down and are like, okay, like, do we all agree and like really study each question? By and large, the way that we actually work is unless we see some kind of deep controversy, we actually could just get 3x the bandwidth. Like any one of the leads will just be like, yeah, there's no controversy here. There's clear consensus, go. Like just go, let's make this official. And the fact that we can do that allows us to be really rapid, really like it's very cheap to go and get a decision from the governance process. But when we do see controversy, we can kind of step back, the 3 of us can chat. We have different perspectives, right? We have different views on things. I have had my personal pet favorite aspect of the design of Carbon overturned by the 3-person governance model. I'm still a little salty about it, but it's okay, right? because we made a decision and we're able to move forward. And I think that's just really, really important. I think people often undervalue how useful it is not to have like the best governance or the right governance that always gets the right answer, but a governance that is definitive and easy to ask a question of, just to make decisions quickly and easily. And sometimes they're wrong. Most decisions are reversible if they're wrong. Like if we get it wrong, we'll find out and we'll be like, oh, that was a bad idea. We're going to go the other way now. And so instead of trying to optimize for making kind of the getting to the best outcome, we're actually optimizing for having the least cost to get to an outcome. And I think that's a really interesting, different perspective on governance and how to set up governance. Now we're still really early, and so like we have a plan for scaling, but we haven't done anything with that yet. So time will actually tell on the scaling side of this, but I think that's more in the future.
Okay, just to remind me how big the team is currently and how many companies are joined.
I mean, I don't know exactly how many companies, but I mean, Google is definitely the main company. I don't know of another one that's like very active. We talk a lot with some other companies. We talk a lot with Adobe. We've talked a lot with a couple of other companies. But I think it's like 5 to 10 people are talking and active on Carbon in any given week. Sometimes it's a different, like there's some rotation, especially as any open source project, people have time and they don't have time. It's normal. But I would say that usually about 5 to 10 people are super active.
Okay, you said at first that it's, and maybe Richard was it, that it's kind of like you solving problems with C++ you had in your code base. And I know that you are aiming to be like compatible with C++. And yesterday we talked and you mentioned that it should be 100% map, you can map C++ into Carbon. So what's the, like, I never heard about Carbon. How do you sell it to me?
How do you sell it to you?
Why should I use C++ developer use Carbon?
Yeah, I mean, the key thing here is I think we can provide a better language, right? Something that's going to have better performance, better tooling, a better ecosystem, without having to leave all of your investment in C++, your existing C++ code base, all of your training in C++. You're not going to have to leave all of it behind. Right, we're going to try and make both the learning curve and the adoption curve and the incremental cost of actually leveraging Carbon as low and as smooth of a ramp as possible, because that's actually our primary goal. And then every time you get to use Carbon, you're going to get advantages, and which advantages are going to depend on what you need. In some parts of your code base, maybe you need more performance. We're going to try and give you even more advanced tools to control the performance of your code. Other parts of your code base, you're going to need safety. And maybe we can ship some safety features more rapidly than we're able to with C++ itself. And when you use Carbon, you're going to be able to pick those features up. You're going to get to benefit from that. And so I think for me, that's the real idea, is like having the ability to unlock improvements in the language, any improvements in the language that matter to you, without having to walk away from your investment in C++, because it's just too valuable, right? We can't stop investing in C++. C++ isn't going to go away. It's not going to vanish. There's way too much code, way too much of an ecosystem there.
Interesting. Richard, do you think it's possible to get something like borrow checker into Carbon?
I think it's possible to get something like that. I don't know exactly what shape it's going to take at this point. It's something we're intending to look into, I think, between the 0.1 and 0.2 milestones, currently the timeframe we're looking at for that. But yeah, we definitely want something in that space, and borrow checker is definitely an interesting direction to pursue, but there are other options there, and we need to figure out what's going to work best for a language that wants to have smooth interop with C++ in particular.
I'm really excited about that. So yeah, we have a lot of time, and if you have any questions in audience, it's not just us. I'm just like pre-warming them for you. And yeah, we should continue. And meanwhile, what's your favorite part about the project? Like, it's like, I think currently 6 years you are working. Yeah, it's like 6 years.
No, it can't be 6 years.
Yeah. It's like since I first heard about it, so.
I think our first commit was 2018.
Okay. I don't know. What's your favorite part?
I mean, I think for me, it's really unlocking the ability to improve the developer experience, like improving the language syntax, making things more understandable, but also like C++ is really slow to compile. And like, if you compare an equivalent file and compiling with Clang, we're hoping for like a third of the time, and most of the time actually being LLVM instead of the language front end. Like, that's really, for me, like improving the developer experience on the whole.
I think for me, from a language design perspective, being able to go through and systematically re-examine like every single decision that was made to get C++ to where it is today, and think, given what we know now about how that worked out and about advances in programming languages since these decisions were made, how can we do better?
So you are choosing good default.
Hopefully. But also trying to retain the ability to change the defaults, at least before things become too cemented.
I'm trying to think what my favorite part is. That said, we do have microphones. Like, if you have questions, like please queue up. So I think probably my favorite thing is it's similar to the systematic thing, but for me, it's not the systematic review that really gets me excited. What really gets me excited is we keep finding aspects of the language that we've basically, we're building this with an eye at C++. We're kind of looking at how C++ works. How do we need our language to work so that it fits together and it like connects to C++? And this means that we have to design a really big, complex language right out of the gate, right? We have generics and templates and inheritance and methods and overloading and, I mean, just so many language features out of the gate in order to fit into C++. But when we look at this stuff, we keep finding these incredibly principled designs and small kind of focused designs that we can use to underpin a really remarkable range of language functionality that is in C++. And all of a sudden it starts to make sense now. It all fits together and you're like, okay, this is like a coherent, really nicely principled language design, and we're writing it down. And so something that I think a lot of people don't realize is that Carbon is basically writing down all of the design ideas from the very beginning of the language design process. We didn't, like most languages, they start with a largely working design. And then they have like an RFC process or some improvement process that documents the deltas from that starting point. Our starting point was 0, right? It was just empty. And we have actually these actual written proposals for each step. And they keep kind of pointing out like, okay, we can take all of these disparate pieces of language design, we can pull them together, we can put them on top of this principled foundation, and now they actually work. They work well together, we can reason about them. It's not just kind of, this collection of complexity. It actually has a framework to it, it has a meaning to it, and that I think really satisfying.
Okay, we have 2 questions from audience.
Yeah, hi. So the title of the talk talked about some design trade-offs being made in Carbon. I was wondering if you could expand on some of those trade-offs a little bit.
I mean, I'll offer one big trade-off is the choice to go for Semmer versus a traditional AST in the language.
What's Semmer?
So we have this, in Clang, what you have is the language is represented as the Clang AST, and this is basically the language model most people are taught. It's very understandable, you can traverse it, and it's sort of how you think of a programming language because that's how you're taught. In Carbon, we have this semantic IR model, Semmer, where we go pretty much straight from, well, we have a more layered approach, I should say, where we produce Lex tokens, then a parse tree from that, slightly different from an AST because it doesn't include semantic information. And then it becomes Semmer, which is more of an IR layout. And I would say it's very efficient. It's very fast to process. It lowers to LLVM IR very easily. But at the same time, it's a different model and a different way to think about writing a compiler. And to the earlier point about newcomers, it's also something that people have to learn in order to contribute, and a bit of a barrier because of that. We try to address that as much as we can, and but it is a trade-off.
And from a language design perspective, we've made trade-offs along the lines of our syntax is designed to be very easy to parse, even in cases where this means sometimes we have an additional keyword that you don't have in C++. So it's unambiguous from the ground up, and that supports things like parsing before you do any type checking.
I think I remember you have like some goal for performance about parsing. Can you share it here, just to get people excited?
I don't remember what numbers.
Numbers are, so our goal is to lex and parse 10 million lines of code a second on a single thread, and to like semantically analyze, syntax check, and like determine that the program is correct at 1 million lines of code a second on a single thread. And for context, right, that means that if you have like a 5-core-ish laptop, like you should be able to syntax check the entire LLVM project in like a second with some parallelism. So that's the kind of compile time speeds we're really aiming for. Super early on, but so far we are on target.
Yeah, I want that. And if you be able to convert C++ into Carbon, you can measure it. And
Yeah.
I sense a talk about it.
There's one more trade-off that I do want to mention that I think is really interesting, because this gets deep into the language design kind of philosophy. One of the philosophical goals of our language design is we don't try to solve hard problems in the compiler. It seems like a weird way of phrasing this, but this keeps coming up in the language design, where there are kind of two designs for how the programming language works. One of them, the compiler has to solve a really deep, complex problem, but the programmer doesn't. The programmer gets to like ignore that, and the code just does what they need, right? And another way of doing this is to like force the programmer. It's like, well, solve it. Like figuring out what you wanted here would be a hard problem to solve, like an algorithmically hard problem to solve. We're not going to do that. We're just going to ask you to tell us. So here's some syntax. Here's a different way of writing it that makes it unambiguous what you mean. A classic example here is like type inference, right? You can imagine having like Henley-Milner type inference, where you try and find the best type looking across an entire statement, right, to figure out how to type all of the different sub-expressions. That's a hard problem to ask the compiler to solve. It makes ergonomics better in some ways, but it makes the compiler solve hard problems. And Carbon's really looking at going kind of the other direction in terms of language design. We say like, no, too hard of a problem to solve. Let's use a much simpler, much more direct and explicit type system instead. And you see this crop up, like that's a simple example, but you see this crop up all over the language design. We'll be, neck deep in some weird part of the language. We're trying to solve a hard problem. Like we've gone about this the wrong way, and we'll back out. We'll try and find a different approach that just doesn't have the hard problem there. And I think it's a really interesting trade-off to make. It's resulted in some different designs.
Okay.
Yeah, so I'm really interested and fascinated by the fact that you're using a lot of ideas from data-oriented design in the front end and making, hitting those kind of performance numbers. So that's pretty amazing. I'm kind of wondering, what are your thoughts on using similar ideas in the back end, whether, improving LLVM or maybe coming up with something new?
Yeah, I think that would be a really exciting thing to explore. The keynote this morning, I think, on MLIR performance highlighted that we're paying some real penalties there for a very pointer-heavy, memory allocation-heavy approach to representing programs. And I think there is definitely an opportunity there to explore a different approach.
But it's also a trade-off.
Yes, absolutely.
Right, because when you take a data-oriented design, you kind of, by necessity, have to specialize a lot, right? And you have to pick, okay, I'm going to solve this very narrow problem. And so I think where you want to apply that is tricky, right? In the front end, we think we can get a lot of benefit from this, but it comes at a cost. There's basically nothing reusable in our front end, right? There's no common infrastructure. We don't get to reuse any common infrastructure, and other folks can't reuse ours because we're specializing in that way. So the question is, right, where in LLVM does it make sense? Is it worth it? And like you don't need extensibility within that, right? And it's worth it to get the performance. So I think it's a really tricky trade-off question to go and find the right opportunities, but also exciting.
And I think another tricky part of this is supporting mutability in a data-oriented design. That they work really well when you're doing things that are more write-only.
Awesome, thank you.
Okay.
So I'm not super familiar with Carruth, so probably a pretty naive question. I'm just curious, how do you guys reduce the computation time? Because also in the keynote in the morning, that says like for module, the 70% to 80% time is spent in LLVM because LLVM is slow. But I just heard that you guys can reduce the computation time to like a third compared to C++. So what's the magic here?
So I can sort of speak towards the metrics Google has. When we look at like a week of builds across the company, we see roughly 2/3 of build time, about 60% is spent in the Clang front end, just doing the parse for the AST, and then 30% is in CodeGen, and 10% is stuff like loading modules or things that it's difficult to actually pin down. So when I say dropping compilation time to a third of what it is today, that's where Chandler was mentioning if we're parsing and doing semantic checking on code at like something the size of LLVM in a second, then the consequence of this is that the front end cost is negligible compared to the back end. And the way we achieve that, though, is through stuff like Carbon is a context-free grammar. And one way that crops up as far as Costco is if you see something like int in C++, it actually takes a little lookup into the parsed AST so far in order to figure out that first, it's a type, but also what's the semantic meaning of that type? Like, how do you evaluate that in a type expression? Whereas in Carbon, it's much simpler. We just have at the parse phase, we know that that's going to be a type expression in an appropriate position. So I think the different design of the language is actually thinking about how do we compile faster. We're making a lot of these trade-offs up front, very much, these two are very experienced with the bottlenecks of the Clang front end. So we're taking those lessons and applying them forward.
And another thing is, even if we're still spending a significant amount of time in LLVM, if the front end is incredibly fast, that opens up a lot of opportunities for tooling to really go very, very fast.
Thank you.
Thanks. Can you elaborate a little bit on governance model? And let me give some background to my question. I have to deal last years with another language that came from Google, Go. And I find the community to be very non-inclusive. And I believe this is a very deliberate choice on part of Go team, because for good reasons, we wanted the language to keep being clear and stick to original goals. Right? But in my opinion, this became a real bottleneck in the development of Go toolchain language. So what's your thoughts on this? And a very specific question.
Sure.
Do you think it will be possible in the near future to commit code into Carbon compiler and core libraries without being signed by a Google employee?
Sure.
Which is still a requirement for Go language.
Sure. So I can't speak to the Go language. Like, I'm not on the Go team. You'd have to ask them. Google is a big place. We don't all know everything about every other project, I'm afraid. But I can talk about what we're doing with Carbon to try and make sure we do remain inclusive. We do remain open to kind of a real open source community. A lot of this just comes from my experience working in the LLVM and the Clang community, and I think it's a really wonderful open source community, and it's been really effective at not kind of being one company or one group that's dominating that. We really want to replicate that to the extent we can. So the first thing is all of the governance discussions take place in the open. So there's not like internal to Google or any other kind of forum or anything. The chat rooms are open. All of the other things are on GitHub. And we actually, in the governance process, we document that any time that we're going to make a decision, we actually have to discuss and explain that decision in public on the GitHub issue tracker. And so the community can respond very directly and say like, no, like you missed this post 3 posts back, which like contradicts everything you're saying. And we revisit it. We've even had that happen. There was a decision that was posted and someone pointed out in the open that like, you all don't seem to have a rationale for this decision. Like, that's not okay. And it wasn't. And like, we went and we like provided a bunch of rationale for the decision. The other thing is we do want to kind of get away from having too much like bias here. So right now there are 3 Carbon leads, right, that make up the leadership. Myself, Richard, and Kate Gregory. And 2 of us do work at Google, but we actually think that's a bug. I mean, it wasn't a large community at the start. Not a lot of folks wanted to volunteer to be a Carbon lead when the project didn't even exist. I'm really, really thankful that Kate has done that. She remains just amazing as a lead and does keep us honest because she doesn't work at Google. Her background is working on like Windows software, and so she challenges us, right, in all of the good ways, and that's what we want to kind of keep. Long term, I would expect that we try not to have any one kind of organization with more than one person in the Carbon leads, just so that there's always a bit of a balance, right? And there's always a sense of a community voice here, and the community can really engage and push for the changes that they want. Those are kind of the key things I think we're doing.
To speak directly to committers, we actually already have a few people from the community that we've given commit privs to.
Yeah.
Like, we want to encourage that, and it's of course based on they contributed a few changes, extraordinarily helpful, and it's something we want to recognize. I think we're trying to be very open here.
I wasn't aware that one of the leaders is actually not a Google employee. That's encouraging.
And one thing I would add as well is that we have an explicitly written down set of goals for the project and where we want it to go so that our community knows the kinds of directions of proposal we'd be interested in and the kinds of things that are not entirely aligned with where we want the language to be. And that means that we have a lot more ability to say, this is why we're heading in this direction or that direction. And I see our job as leads as, in large part, analyzing proposals and seeing whether they go in the direction of the goals or not, rather than whether they satisfy our own personal desires.
And the goals also are mutable.
Yeah.
And so like people can say like, actually, you all don't have this goal and you need it. And then we can adopt it. And that's the way that, right, the community can actually influence the direction of the project as a whole.
Mm-hmm.
Thank you.
I just wanted to ask, how does how does the language compare to languages like Rust?
I think Rust is an awesome language. I think something we explicitly say in our documentation is if Rust works for you for your project, you should absolutely use it. It's just really well designed, well thought out. I think probably the big differentiator is that we have a strong emphasis on C++ interoperability and the ability to migrate C++ code into Carbon. And so we have language features like classes and inheritance and templates and things of that kind that are going to be super valuable if you're coming from a C++ mindset or a C++ code base. But in terms of like the overall philosophy, I think there are some similarities between Carbon and Rust. Things like we have a checked generic system that's fits really nicely into our template system, but it's a little bit different in the way it works. And other kind of modern type system features that you really expect to see in a modern language.
Thank you.
Also, Rust exists and like is mature. I just want to also point out like we're at very different phases of development.
Yeah, so years ago, when I first heard about Carbon, I was skeptical but also excited. New languages are in a dime a dozen. But one of the things that you guys were telling me was a design principle was to be able to change the language later on and be automatically migratable. And that sounds very good, but it's still abstract to me. Can you make some concrete points of what you are doing to make that migration possible in the future?
So I think part of this is the governance style. I would actually start with that first because part of evolution is the ability to actually make decisions and move forward. And certainly a willingness to say we made bad decisions before. And, even if that means, say, breaking an API, renaming a keyword, which is going to be disruptive, breaking API compatibility, there are some important things that can really yield good improvements if you're willing to do it. But then there's also the question of how you get there. In much the same way that we're talking about building a migration tool from C++ to Carbon, one of the benefits of Carbon being a clearer grammar to work with is that we should also have it be easier to upgrade from one version of Carbon to another. So if we do decide to add a new keyword, for example, we're building paths to where we can do that without substantially breaking code. So that we can actually give people a clear migration path where they just run a tool, and that's a little effort, but they don't really have to go through the code themselves. They should be able to rely on it being an automated process versus a manual one.
So clear context-free grammar is the most important point, you think? Is there other places in the language where...
I think that helps, but I actually don't think that's the most important point. I would actually say the most important point is actually the tooling ecosystem. When you look at C++, everyone has a different C++ set of tools. If you want to ship a migration tool for C++, first off, it's very hard to write because of the grammar. But then, everyone has a different build system, a different compiler, a different tool chain. There's not this common place where you're definitely going to get all of your users covered by a tool. And one thing we can do with Carbon is we're not a standards committee. We're not limited in what we ship. We can actually ship tools. And we can do that from the very beginning alongside the toolchain and the compiler so that they get deeply embedded in everyone's workflow. And that's going to kind of really, really expand the availability of this kind of tooling. I don't know. Maybe that's more important. Maybe it's not. Both are important.
I think another factor is that a lot of the things that are language features in, say, C++ are exposed more as library features in Carbon. And that means that all of the functionality that we have available to make it easy to make library evolutionary changes allow us to make changes that in other languages might be language changes.
I have a super specific syntax question, but maybe you can use it as an example for how the decision project in the Carbon community works. So when Carbon was first announced at CPP North, my biggest beef with C++ was the difference between pointers and references, like the LLVM coding standard says, if it cannot be null, then you should be a reference, otherwise a pointer, which has as a consequence that when I want to change the signature of a function from accepting null or not, I have to change all the users in the function. And usually in the function body there's something, if not argument, so it's null, then return immediately, and everything else you can assume it's non-null. So when I then looked in the Carbon discourse, I think there was look for a discussion for exactly that thing. I found that Carbon wanted to retain this thing. I think things then I looked again and it was changed again for the syntax of it. So what's the state of that? So how does the decision process around for this, for instance, works?
So the current state is that we don't have references, we only have pointers. And our pointers are non-nullable. If you want a nullable pointer, you can have an optional pointer instead. And our pointers are expected to point to objects that are not array iterators in the way they are in C++. And a big part of that is when you have a pointer type in C++, has a very wide interface. It provides you with a lot of capabilities, and most of the time you don't want most of those capabilities. And so there's kind of a safety aspect of that and a correctness aspect of that, and also just an expressing what your intent was aspect of that. And so our normal pointer type is very restricted in the sense that it's a pointer to an object that isn't indexable that isn't nullable. Someone else wants to take the evolution side? I don't remember the path we took to get there.
I mean, the only thing I would add is, right, like having a type difference between nullable and non-nullable pointers, whether it's references and pointers or some other type difference, I think is important. Like really, really important, because this is something that allows people to actually not have null pointers that crash their program. We keep getting more data on this. I mean, this was the $1 million mistake, famously. There's plenty of data about this, and so it is a little frustrating to have a syntax difference between nullable and non-nullable things. But there's a reason for that. It's because we want to model this in the type system and get the type system's help, checking and enforcing that the code is correct and safe.
Thank you.
Hi. I have a follow-up question for the previous question regarding why Carbon, not Rust. I got recently. I found out about another project from Google called Carruth, which basically aims to do for Rust almost the same thing that you are trying to do with Carbon. So the function level interoperability between C++ and Rust by allowing all of the features that are currently missing in Rust that you mentioned that you have in Carbon. So do you have any interoperability with that project? I think they even mentioned that they were inspired by Carbon, but they just want to use something more mature and that exists.
I mean, the Carruth team and our team are really close to each other. They're doing amazing work. I think the key thing to think about this, though, is that Rust was not designed around C++ interop, right? It was designed as its own language with deep ties in functional programming and safety and like type system-based guaranteed safety. And Carruth is trying to build a bridge between these very different language designs. And they're gonna keep adding to that bridge and making it better over time to try and get as much interoperability between C++ and Rust as we can get. But we have a very different kind of impedance mismatch between Carbon and C++, because we're designing Carbon specifically to match what C++ already has. And that means that we can kind of take it a very different track. In some ways, like we are aiming at the same goal, but I feel like we're coming at it from almost opposite ends of the spectrum in terms of the constraints we have to overcome. Like best case, both of these are successful because we've got so much C++ code in the world, right? Like the Rust code bases need access to it. We also need ways to kind of directly improve it, right? I don't think we're going to have 0 C++ in 5 years and 100% Rust, even if we put every engineer working on it as hard as we can. I just don't know that we can get there. And so I think there's a lot of utility in having a diverse set of tools to tackle that with. We're actually even talking with the Carruth team, because at some point we're going to need Carbon Rust interop. And Carruth is exactly figuring out kind of what that needs to look like, how to get to a language that has a different design, how to kind of mediate all of the rough edges that emerge. And there are a lot of them, especially around safety. I mean, it's not Carruth's fault or Rust's fault, but like it's really difficult to get all the way from a C++ API into something that feels good and is ergonomic and works well in Rust.
Cool. Thank you.
I might add a couple of things. One is I'd put particular emphasis on the difference of memory layouts. Like one of the choices we're making very deliberately in Carbon is to be able to match the C++ memory layout and have that be common. So interop will be essentially free in a lot of ways. Whereas Rust, being a different language, is going to have some level of overhead involved. And I think the team is going to be pretty successful in keeping that low because of the particular approaches Rust takes, but it probably won't be at a level where you can just swap a library from C++ to Rust and not have any concern about performance. The other thing I'd emphasize is even if interop is great, migration is still a huge thing. And the ability to take an existing library and migrate it to Carbon should be very easy. Whereas our experience is taking a similar library and migrating to Rust. You can do that fast, but it takes work. And a lot of organizations with say you have a large company that has been around for maybe a couple decades, has a bunch of C++ history, hypothetically, might not be willing to invest in that kind of migration. At least, some teams naturally will, but not every team. And it's really that broad experience, something that is reachable by every team, that we want to provide.
I was really happy to hear how important you think source tools are, linters and refactoring tools and editors and so on. In C++ world, we need to use Clang because you can't write another C++ compiler just for your parser, rather. But Clang often doesn't have the trade-offs in the right places that we would like for tools, so there's some limitations. It sounds like you expect your front end to be reusable for tools, as opposed to people to write more front ends for the tooling side, or maybe not. Can you kind of speak to that and how that affects the design of the front end and any interesting details?
I think so. I'm pretty confident, at least through the parse tree, it'll be reusable. I'm a little more hesitant to make that claim on the semantic IR just because it's so purpose specific. It would be a little like taking LLVM IR and trying to, or maybe LLVM IR isn't the best comparison, but taking MLIR and trying to go back to the original code and make decisions. Like, you can, but it may not be the best choice for everyone. We may end up wanting to build something that's more of an AST and more usable. But one of the effects of also providing these tools as part of the language project, like, we do want to provide a formatter and a migration tool and something similar to Clang Tidy, say, as part of the language. So we're going to be taking on these costs ourselves, and I think that's going to yield an amortization of costs, shall we say, and trying to figure out the right balance there. Maybe the semantic IR with a few changes might be actually better for everyone, I guess I should say.
Thanks.
Hello. So I'm not really familiar with Carbon, but I was thinking that you mentioned it's been like 6 years since it began, and I knew of the project when it was announced. It felt that it was more recent to me as well. So this question came in mind that C++ has changed quite a lot these past 6 years, and you have a lot of future into development Carbon. So how do you feel that this development of the language affects Carbon? And I see that there may be some potential risks in the assumptions made today about the language. So do you have any strategy into, since you are trying to aim for interoperability and all these things with regards to what C++ is going to become in the next 5 years and so on?
I think from my perspective, one of the key things here is that our interoperability story is actually very specifically built on what kind of this community has produced, which is Clang. And as long as Clang is continuing to implement, the new versions of C++, right, we're going to have the infrastructure we need to interoperate with those new features. So the way that Carbon's interop is going to work is very similar to how the Swift C++ interop works. Right, you're going to link the Clang library into the tool chain and directly use it to understand C++. And so from a technical perspective, I think we have a good way of kind of reliably picking up support for new features, new functionality, whatever is added to the language. In terms of just directionally, is the language going to change in a way that really changes our assumptions or causes us to, like, Carbon to not make sense anymore? If it's the assumptions, that'd be amazing. If C++ becomes, if C++ starts changing in ways that really address some of the safety concerns, some of the evolution and flexibility concerns that we have, and starts moving more rapidly, that would be awesome. I would actually that's kind of the best case scenario. We can shut down Carbon, we can all go back to C++. It's much cheaper. Even with the sunk cost, it's way cheaper than anything else. I don't think that's very likely. Certainly, I'm not seeing a lot of trend lines, and we do pay a lot of attention. But it isn't a bad thing, and it's not something that we would push against. Like that's what should happen in some senses. In terms of like functionality that would just make interop not fit well, that is a little bit of a concern, of course. But this is a general concern, right? C++, if they're going to add a new functionality, they need it to interoperate with existing C++ code, right? And so really, I think the main constraint that we face is also the same constraint that a new feature in C++ faces, which is all of the existing code, all of the existing software that does need to keep working. You can't change the memory model for atomics in C++ 26 because it has to run with C++ 23 and 20 and 17 and 14 and 11 libraries that all assume that memory model, right? And that's the kind of change that would really block Carbon, but it would also block making sense in C++. And so that's not a big risk, I think.
All right, thanks.
I think there are some excuse me, there are some C++ changes that we do need to keep an eye on as they become more used by the community. A big one there is C++ 20 modules, because that's likely to have a big impact on how we get C++ code into Carbon. But at the moment, because modules adoption hasn't taken off in a big way yet, we're still targeting a world with header files.
Thank you.
Hi, I wanted to ask the same question a little differently. So some features in C++ come very slowly, like reflection. And what happens that you guys get reflection in Carbon before C++?
I think that's unlikely to happen.
Yeah, Hannah, like...
Yeah, I hope C++ reflection will be in 26, and we are on good track for that. So I'm not sure Carbon is that fast.
For reflection, that seems hard.
Yeah, we will see who will win, but I'm confident it will be us.
Well, reflection was one example, but what happens is when you have like a feature that you develop because you need it and you can iterate fast and provide design decisions and so on, and then what happens in the C++ community, we see features that are nice and here and there, and then somebody proposes them and they move forward in some very weird way and so on. But what happens to your model in that case?
I mean, I don't know. I feel like this. We should be so lucky as to have this problem. I really hope Carbon is successful enough to add features faster than C++ and that cause a problem. I think we've got a bit of a road before that gets there. But if we get there, right, like the reason we're going to get there is because Carbon is in some way successful. People are using it; they're benefiting from it, and I hope that the standards committee is paying attention to that, and then maybe we can find good ways to kind of leverage the fast iteration we do in Carbon to inform C++ features, and maybe they can actually kind of evolve together. I don't know that they need to kind of go in separate ways. One reason we are publishing everything we're doing in the open is because we want people to actually like read it and learn from it. We have the benefit of looking at how Rust has evolved, how Swift has evolved, how even Go has evolved, how all of these languages have evolved over the last decade, and we benefit from that, and we want to contribute back to that, and hopefully that also helps the standards committee, and that's something they can also look at.
Okay, it seems we don't have any other question.
I can ask one more.
Oh, okay. Sure.
So, since there's languages that are happening, and people are rethinking the way that we express computation nowadays, because now we have scale, we have hardware, we have ML, and so on. I was wondering, when you develop like a language, of course, you talked a little bit about your toolchain and your intents on the toolchain side. But in terms of governance side, you probably have reviewed all of the spectrum of like governance and so on. And it seems like I do not follow very closely what you guys are doing, but to me, as an outsider, it seems like you are a little bit following the Swift approach in terms of governing, when you have like a small central team which helps to keep experts and then maybe personalities and so on. What is the difference? Are you like following that approach, or you want to make something different. And I'm saying that because, Swift had a great adoption within a couple of big companies, but it still needs to make the second leap so that it can be widely adopted and say, okay, we won, the industry as a whole.
Okay, I can't speak for the Swift folks. There are Swift folks here that maybe can speak to that, but on the Carbon side, right, the thing we're trying to do really is we wanted to make sure that every step of how the governance actually operated was something that was in the open and reflected something that the community could participate in. Right? We can't make decisions with 200 people. We can't scale decision making up infinitely, but we can make sure that all of the communication, all of the discussion, and the priorities, like what the basis of the decision is, like why are we going to make decision A versus B, needs to be something that we kind of document ahead of time, we share publicly, that the community has access to. And I think kind of going as far down that path as possible is one thing that we're doing that's a bit different. And in particular, I think having the why, the goals, the prioritization, really precise upfront and kind of broadcast initially is a huge change. Like we've said exactly what problems we want to solve with carbon and what problems we don't want to solve with carbon. I think that's super important, and it helps you design and helps you govern in a way that is actually transparent. And is as open as it can be when you are still ultimately making a decision, right? Not everyone's going to agree with every decision. What you really can do is you can be transparent. And that goes to how you make the decision, but also to why and how you're going to make future decisions. Like what are the factors that are going to influence the next one and the next one, so that people understand, they can predict it, they can feel happy about how they engage.
You have a last question, then I have one small at the end.
Okay. One question. So next to Carbon, there's also a similar project by Herb Sutter, CPP Front. I guess you get the comparison to it a lot, but let's say bluntly, what keeps the two projects from joining forces?
I think there's a fairly fundamentally different philosophy. From the Carbon side of things, we are trying to imagine where if you evolved C++ and evolved it and you're prepared to drop compatibility with old things, like drop source compatibility in particular, but still keep programs working, migrate them, where do you end up with as a language? Like what does that end state of evolution look like? And so we're trying to get somewhere around where we think that is. I think, I can't speak for her, obviously, but I think from my impression is that he's trying to preserve a lot more source level compatibility, which leads to different sets of trade-offs and different design constraints. Yeah.
Thanks.
Okay, my small question is, I remember you choosing name Carbon. What were other candidates, and why did you choose Carbon, and how did you choose Carbon?
I mean, there are a bunch of candidates, so picking names is really hard. And like not in a facetious way, it's actually really hard to name things. We had a whole bunch of constraints that we wanted on the name, like we wanted something that was easy to search for than C++, easy to kind of say, spell, especially non-native English speakers. Like we didn't want something that was really hard to pronounce. We came up with a bunch of ideas. Carbon wasn't even one of them. We voted on all of them just to try and polled some people just to try and figure out what would be a really good name. We had it. We were so happy with it. We tried to pick that name, and unfortunately some folks came and said no, you can't have that name. There was a product with that name. Absolutely not. And we looked at after we kind of had all this discussion, we kind of argued down every other one of our ideas, and so we didn't like any of our other ideas anymore. That's how we ended up with picking one. And so we had kind of a little bit of a rush to just try and find some other ideas. I continue to think that Mercurial is the best named project ever. I don't know who came up with that, but really well played. Such a great name, so many beautiful puns. So we were looking at elements on the table. I think you liked that it started with the letter C. I liked that it sits right above silicon, right? You see, it's terrible. Look, we needed a name, and so we picked one.
Okay. Thank you all, and yeah, thank you, Richard. Thank you, John. Thank you.